back again, links and cues. So what we're doing this time, adding, subtracting radical expressions. We've already done multiplying and dividing, so naturally speaking we gotta do adding and subtracting. So let's go ahead and jump right into it. There are a couple steps that we need to follow. So when you add and subtract radical expressions, first thing you need to do is you can only add or subtract radicals that have the exact same radicand. That's the most important thing. Then, adding and subtracting only the number on the outside of the radical. Then check and see if you can simply simplify. So, basically this is the combination of what we've been doing the whole time with the multiplying and dividing. But of course you see here, this is the key point. Exact same radicand. If you have those exact same ones, then you can add them up. If you don't, then you gotta leave it alone. You gotta leave it the way it is. So, let's go into a couple things. So let's go through, just go ahead and jump into the first example. For example, we got here. We have a 4 root 3 minus 12 root 3. Now, does this have the exact same radicand? Yeah. Square root of 3, square root of 3. So what do? We just subtract the ones on the outside. So 4 minus 12 gives me a minus 8. Root 3. There we go. Easy and simple. That's our answer. Very simple, very straightforward. Of course, example 1 is always the easy one. Now let's jump into this one. Now we got square root of 32 plus 2 square root of 2. Now I have a couple of words here for you. Now looking at this, you can tell that it's not square root of 30. Square root of 32 I can't add these two because it's square root of 32 and 2. But sometimes you have to simply simplify first, then see if you can add. Sometimes you will be able to add, sometimes you won't be able to add. You just got to check and see. So, let's break down 32. Now, based on what I do, usually, square root of 32 would be 8 and 4. And then that breaks down. I'm going to X out my 8. 4 and 2. Break that down. Now it'll be 2 and 2, right? Now I'll break down my 4. My 4 would be 2 and 2. How many pairs of 2 do I have? Got 1 here and 1 here. So on the outside of this radical, I'll have 2 times 2, right? Root, what's left over? My 2 right here. Now that equals to 4 root 2. Now I'm going to go ahead, broken down, this is 4 root 2. I'm going to go ahead, can I add it to the 2 root 2 now? Yeah, I can. Plus 2 root 2. Why can't I? Because these are exactly the same. So now I just add the outsides, and I end up with a 6 root 2. Very straightforward. So sometimes you can break it down, sometimes you can't. In this instance, we had to really break it down first to see if we can add it or subtract it. And of course, as you see here, we can. So there's our answer. Now example 3. Now example 3, almost the same concept. Now, can I add these two based on what I see here? No, I can't. But what do I have to do first? Can I break down is there something I can break down? Yeah. I can break down this 12. This 12 can be broken down into 4 root 3. That can be broken down into 2. I'm gonna X out my 4 here, and I have how many? I have a group of 2's. So that would be 3 times 2 root 3 plus 4 root 3. And now what's 3 times 3? 6 root 3 plus 4 root 3. And now my answer will be 6 plus 4 gives me 10 root 3. Here we go. Very simple, very straightforward. Alright, that's example 3. Next one. We have this right here. Now we're jumping into the semi-harder ones, but not really. Based on what we've done before in simplifying radicals, this should be very simple. So, the first thing you need to do first, is there anything that can be broken down? Do they look like they can be added together? No. But can I break anything down? Can I break down to 20? Yeah. Can I write down 45? Of course. And what I get here? I'll get, break this down, I'll get 4 and 5. Break my 5 down to be 2 and 2. So how many do we have here? We got 2. So this right here becomes 3 times 2, right? Now, also I have an x to the 4. Now, x to the 4, based on what we learned before about simplifying radicals, the 4 needs to be divided by 2. So, for example, this would be square root of x to the 4 really is just going to be x squared, because that could be, all you got to do is take the 4 and divide it by 2. So now that comes on that, this all the way comes all the way outside. So this would be x squared. And now what I have left over right here, I just have my 5. So that'll be root 5. So 3 times 2, x squared root 5 becomes 6x squared root 5. Alright? Now my next step is this one right here. So this one here, x to the 6. This is an even one. Since we're even, we just divide it by 2, and I get 8x to the third. Go ahead and take care of the variable first. This one right here, the 45, can be broken down into 9 and 5, and then that can be broken down into 3 and 3. And then now I have 2 pairs right here, so this becomes, so this now becomes, and I'm going to go ahead and put it right here, 8x to the third times my 3 here, root 5. So now I'm going to simplify this right here, and I end up, let me change color for a second, I'm going to end up with 6x squared root 5 plus 8 times 3 gives me 24x to the third, right? Root 5. And now I have these two, since these are the same, I can add them together. And I'll end up with a 6x squared. Well, I'm going to go ahead and put it in standard form like we've been doing before. So 24x to the third, 24x to the third, plus 6x squared root 5. And here's our answer. Very simple, kind of complicated, but pieces everything together we've been doing, it should make perfect sense. Now, I have one more for you, one more example for you, and it's pretty simple one. So, but I just want to make sure everyone understands what we're going to do here. Actually, I might do one more after this. So we got, first of all, what we know about these. They're all the same. So this one's very simple. We have 5 plus 4, which gives me 9. Right? 9 root 10 minus this one right here, root 10. And this breaks down into simply 8 root 10. So with 3, we just make sure we all got the same, and then we subtract it. So this one's very straightforward. Just want to do a couple with the 3 of them in there. And let's actually go past this one. I think this one's another one that I really like that I want to do. So, now, do these look the same? Do these look the same at all? No, they don't. Can we add these? Well, at first you look at it, you say no. But is anything be broken down? Can 8 be broken down? Yeah. 8 can be broken down into 4 and 2. And now this comes down to cancel this out, 2 and 2, right? I have a group of 2 of those. So I really have 2 roots, 2a, see where I got the 2a from? Minus square root of 2a. And when I add those, when I subtract those, this has an understood, what does it have an understood what? Understood 1. 2 minus 1 just gives me 1, so really it's just root 2a. There's my answer. Okay guys, so we've gone over adding, subtracting rationals, radical expressions. These are pretty simple, pretty straightforward. If you understand how to simplify radicals, this is really just a couple more extra steps. So key things you need to focus on: if the radicands are the same, you can add them or subtract them. If they're not, you basically put them together, but you can't do anything to them. You can't add them nor subtract them. Also, another thing that you want to also be very wary of, make sure, just like in this example, you could break this down. So please, take your time, rewind me, go try to do some of the examples I did on the board, make sure you have it. But I think this should be a very good thing you should do well on. If you have any questions, like I always say, talk to me, Miss Black, or Miss Glover, and I hope this helps. Y'all have a good one. Later.